Okay, in this video, I'm going to work through the problem that's shown here. So I'll start by reading the problem. It says the original Ferris wheel, designed by George Ferris, had a radius of 125 feet and premiered at the Chicago World's Fair in 1893. If a person boards the Ferris wheel from the bottom at ground level, ignoring seat height, how high off the ground is the person after they have traveled 100 feet around the wheel? Then the directions are draw and label a diagram to visualize the problem. So let me highlight the instructions so I make sure that I don't miss any of them. So draw and label a diagram, show each step as you work through the problem, and explain the purpose of each step. So be specific. So there's three things that we're doing here as we go ahead and try to find what's actually being asked. And what's actually being asked is how high off the ground after traveling 100 feet around the wheel. All right, so I'm going to start by drawing this out. So the original Ferris wheel has a radius of 125 feet. So I'm going to start by drawing a circle. Oops, let me try that one more time. I'm not the best circle drawer. Had it go in there for a minute. I'm going to start by drawing this circle. That's good enough. And the radius of the circle is 125 feet. So we know that means from the center down to here is 125 feet. All right, and we know that the person is getting on at ground level. So right here, the Ferris wheel is sitting on the ground, and the person is getting on right here. Let me change color. The person's getting on right there, and then they're traveling around the wheel 100 feet. Now, 100 feet is a little bit shorter than 125 feet. So I'm going to estimate it's about this far that they're going, that distance, maybe not quite that far. Maybe they end up here, okay? And so I want to know then, the question is asking, how far off the ground is that person at that point? So right about here, I'm looking for this distance D, okay? Let me put it a little bit closer. Well, actually, I'd like to put it out here where I had it, just so you can see what's going on. So that's the distance D right there that I'm actually being asked to find. Okay, so now we know a few things. We know that, I'm not finished labeling, I guess. I know that this is 100 feet, okay? And I know that from the work that we've been doing that I can use the sine function to give me the height from the horizontal axis. So in other words, I could find this distance here by using the sine function, but I would need to know what? I would need to know the angle that was formed from the 3 o'clock position. Remember, the sine function is defined as if I start here and wrap around wherever I end up, the distance from the horizontal axis to that point is the sine of that angle. Okay, that gives me the distance from the horizontal axis, starting at the 3 o'clock position, wrapping around. So, all right, well, what do I know? Gee, do I know any angles? At this point, I don't, but I do know there's a relationship between angles and arc length, and that relationship is given by S equals theta R, where S is the arc length, theta is the angle that's swiped out, and then R is the radius length of that given circle. So if I come back up here, I have an arc length, I have a radius length, so I should be able to find the angle that was swiped out. So in other words, I should be able to find this angle right here. So in this picture, I'll call that theta for now. And I can then say S, which is 100, equals theta times R, which is 125. So 100 divided by 125 equals theta. And so that gives me 0.8 equals theta, and that's in radians. I do not need to go ahead and find the degrees that's equivalent to that. I can just leave it in radians. And so I will for now. If you turn it into degrees, that's fine. It's just an extra step. And if it helps you to visualize it better, go ahead and do it, but it's not needed. You can just think in terms of radians. It's good to get in the habit of being able to think in terms of radians as well as degrees. So that is 0.8 radians is theta. Now, remember though, over here, just a minute ago, we talked about the sine of the angle giving us that that vertical distance from the horizontal axis. However, that was when the angle started from the 3 o'clock position. Here I have an angle that's starting from not the 3 o'clock position, from let's say the 6 o'clock position on a clock. And moving this direction, I got theta. So that's not exactly what I need. And there's a couple different ways you can think about this. One is you can say, well, I need to find this angle, this total angle here, because then I could just use the sine. Or I could drop down here counterclockwise and find this angle right here counterclockwise and use again the sine function, because whether I go clockwise in this direction and find that angle or counterclockwise in that direction and find that angle, both of those angles have me ending at this terminal ray where the position of the person on the Ferris wheel is. So I'm going to go ahead and find this large angle here. So in radians, I know that when I swipe to the vertical here, I have swiped pi over 2. So to here is pi over 2. When I go halfway around the circle, that's pi. And so then down here is 3 pi over 2. Let me write those in. So up here is pi over 2. Over here is pi radians. Down here is 3 pi over 2. And so the angle that I want to take the sine of, 3 pi over 2 plus that 0.8 that I just traveled. Okay, now I can just go straight to Desmos and do this. Let me pull up Desmos here. Okay, so I can take the sine of 3 pi divided by 2 and add to that 0.8. And notice I'm getting a negative 0.6967. And since I just took the sine, that meant that I was actually taking the sine on the unit circle. But we know that we are on a Ferris wheel where the radius is 125 feet. And so in order to find that distance here, the distance from here to here, I actually need to remember to multiply by the 125-foot radius because I am not on a unit circle and I need to account for that. So let's go back over to Desmos and make sure we include that in there as well. And now it shows you that you are negative 87.08. And why is it negative 87? That is because, remember that we dropped down. That's why it's negative. So I'm going to go ahead and label this now. So this height right here from the horizontal axis down to that point where the driver's sitting is 87 point, oh gosh, I forgot already. 87.09, let's say. 87.09 feet. Okay. Now, some of you are saying at this point, oh, I did all that and I got a different answer. I got a different answer. How come I got a different answer than that? And it could be because right over here in Desmos, you have to tell your calculator, whether you're on your TI or on Desmos, you have to tell your calculator if you are working in radian mode or in degree mode. And so if I come over here, that's how you change it on Desmos, you click on that wrench, and down here at the bottom you see, oh yes, I am in radian mode, which is what I want because I'm using radians. I didn't convert to degrees. If you had this in degree mode, however, see, you would get a different answer. Notice how that negative 87 changed to 12 when I switched to degrees. And so if you were working in degrees and you forgot to change your calculator to degrees, you would get a different answer. So it's not that your conversion to degrees was necessarily wrong. It's just that you were in the wrong mode on your calculator, potentially. Okay, so now we come back over here and we found out that this was the negative 87.09 feet. So we're pretty close to getting our final answer. This 87.09 feet right here is the distance down from the horizontal to where the person's sitting. We need to find out the distance from where the person's sitting to the ground. The total distance from the horizontal is 125. So now at this point, I can take the 125 feet and subtract from that the 87.09, and that would give me the distance that I am above that ground level. So let me come back over here. 125 minus 87.09 gives me 37.91. So let me go back over to here, and I get 37.91 feet. So my D here is 37.91 feet. And that is the answer to my problem. So I will go ahead and put a box around it. And I will say that the person is 37.91 feet above the ground after traveling 100 feet along the edge of the Ferris wheel. There were three main steps here. The first one was that I needed to find the angle that the person had traversed. Then I need, well, kind of four steps because this second step here is broken into two parts. I first needed to then adjust that angle in order to be able to use the sine function. Then I used the sine function to find the vertical distance from the horizontal. And then I used just the fact that the radius was 125 feet and that I was 87 feet below the vertical, below the horizontal axis. Sorry about that. And to find out my total distance above the ground is 37.91 feet. All right, I hope that helps. Well, before I close, actually, I want to say there's multiple ways to do this problem. If you did a different method and you want to know if your method was valid, One way is, did you get the same answer? That's a pretty good check. Another thing is to compare what you're doing and how it makes sense with what I did, how it compares. And the third way is to go ahead and ask one of the tutors or myself if your method is equally valid, and we can have a discussion